What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 13, Section 7, Probability. Let's do it. What term is used to express the likelihood of an event occurring? Are there restrictions on its values? If so, what are they? If not, explain. So when I say what term, or when I answer what term is used to express the likelihood, I would say probability, right? What is the probability that something is going to take place? And we're talking about restrictions. There definitely are restrictions. Now remember, probability is the odds something is going to happen, and those values are going to be between 0 and 1. They're kind of equivalent to percentages, right? Like let's say if it was 0.5, that's like a 50% chance that something is going to happen. So those are the restrictions. It's going to be everything between 0 and 1 inclusive. That's how you do it. Done. What is an experiment? An experiment, according to the back of the book, is an activity with an observable result. But basically, if you want to break that down, it's just the process of carrying out an action, right? So let's say as an example, if you want to know the likelihood or probability that you're going to roll a 5 on a dice, what you might do is you'd actually roll that dice. You'd roll it 10 times, 20 times, 100 times, measure all the outcomes, all those observations, and then calculate a probability based on those results. That's, again, experimental probability. The union of two sets is defined as a set of elements that are present in at least one of the sets. How is this similar to the definition used for the union of two events from a probability model? How is it different? So let's just flesh this out. You know, we're talking about two sets. Let's say 1, 2, and 3. We've got a set of 3 numbers. And then we've got, let's say, 2, 3, and 4 in the second set, right? So the union of these would be basically joining them. Now, this one's got a 1, so we add that, and then they both have 2s, they both have 3s, and then this one has a 4, right? So we're combining all of those unique items into one giant set. That would be the union of the set. Now, we're talking about unions of probabilities. We're joining the events together. So, for example, if I say, hey, I have a certain probability of rolling a 5 on a dice. I have a certain probability of rolling a 3 on a dice, right? Both of those would be 1 out of 6. The union of these two events would be the probability of rolling a 5 or a 3, right? So either would hit that. So that's kind of the similarity. We're kind of combining. And then the difference is, you know, in a union of sets, we end up with this final set that contains both of the elements. With a union in terms of probability, we're almost creating a new event. It's, again, not just a 5, not just a 3, but in this case, what's my likelihood of getting a 5 or a 3? Anyways, that's how you do it. Done. So for this question, we're looking at this wheel and we're asking, what's the probability of landing on a vowel? So remember, when we think about probability, we want to look at all the different outcomes. That's going to be my denominator of probability. So we got 1, 2, 3, 4, 5, 6, 7, 8 different options. And then probability is, now we have to choose the winners. How do we win in this case? They're talking about vowels. So that's what goes on the numerator. How many vowels do we have? 1, 2, 3, and 4. So we've got a 4 out of 8 chance to land on a vowel. We could reduce that to 1/2. So my probability of landing on a vowel is 1/2 or 0.5. Either way, both are correct. That's how you do it. Done. So this one says landing on purple or a vowel. And again, we've got how many choices in total? We've got 8. So this is an or. This is a union situation because we see that word or. So we're going to count up all the purples and all the vowels. So looking at this, we're going to count up everything that's purple or a vowel. I think this is supposed to be purple. It's hard for me to tell, but let's say B is a purple one. And then we've also got the vowels A, I, E, O. So when we say purple or a vowel, it's like we can get either a vowel or either purple. So we combine them all into one big set. So how many choices do we have there? 5. So my chances of getting purple or a vowel are 5 out of 8. That's how you do it. Done. So for this one, it says landing on green or blue. Again, that's a union term, right? So we need to count up everything that is both green and blue. So we got 1, 2 for blue, 1, 2 for green. And so again, since we got a total of 8 options and 4 of these are either blue or green, we have a 4 out of 8 or 1/2 probability of landing on green or blue. So 1/2 is the winner. Done. So this one is asking, what's the probability of not landing on yellow or a consonant? So what we're going to have to do is we're going to have to count up both the yellows and the consonants and then subtract that from the total, which is 8. But again, we're starting with 8 on the denominator because that's the total number of possibilities in this universe of the wheel, right? So what is yellow? That's this one, the O. And what is a consonant? That's basically not a vowel, right? Like F, D, C, right? So we've got F, D, C, and we've got B. So we have to kind of combine these all together. 1, 2, 3, 4, 5 different options. So my probability of landing on yellow or consonant is 5 out of 8. Of not landing on yellow or consonant is 1, 2, 3 out of 8, those remaining stragglers. So the answer is 3 out of 8. That's how you do it. Done. For the following exercises, 2 coins are tossed. Find the probability of tossing 2 heads. Okay, so the way we can think about it is each of these coins tosses are independent events, right? So what's the probability of getting a head on the first toss, right? Well, we got 2 options, tails and heads. So I've got 1 chance of getting a heads out of 2 outcomes. What about on the second toss? It's the same thing, right? It's again 1/2. So if we're trying to find the probability of getting head and another head, okay, this is going to be a multiplication situation. We take each of those individual probabilities and we multiply them together to get 1 out of 4. And so that's the answer. We have a 1/4 chance of getting 2 heads. That's how you do it. Done. Find the probability of tossing at least 1 tail. So we're tossing 2 coins in this situation. And what I'm going to do to explain this one is I'm going to show you all the different outcomes, right? So let's say we've got the first coin, we got the second coin. One option is we get heads and we get heads, right? Another option is, again, we get heads on 1 and now we get tails on 2. Another option is we get tails on 1 and then maybe heads on 2. And the final and fourth option is we get tails on 1 and tails on 2. This covers every possible outcome. There's nothing else you can think of, no other combination that's going to be unique. So there's only 4 choices. And they said find the probability of tossing at least 1 tail. It doesn't say for the first or the second. It just says in total. So I've got 1 tail here, 1 tail here, and at least 1 tail. I got 2 tails there. Those all qualify, which means my probability of getting at least 1 is 3 ways to get it out of 4 total. 3/4 is the winner. Done. For the following exercises, 4 coins are tossed. Find the probability of tossing exactly 2 heads. So I'm going to show you 2 ways to think about answering this, right? So think about it. We have 4 coins, right? And we have these different probabilities that we have to calculate. So exactly 2 heads. So we've got a half of a chance, right? 1/2 of getting a head here, 1/2 of getting a head here. And if we're going to get exactly 2 heads, we also have to get tails here and here. We have to. So that's a 1/2 chance of getting tails and a 1/2 chance of getting tails. So this is assuming we got heads, heads, and tails and tails. Again, to get the probability of this entire event, we take the product of all of these, 1/2 times 1/2 times 1/2 times 1/2, and that's 1/16. But this is just one way to get exactly 2 heads, right? That's in the first 2 positions. We could also get 2 heads here and here. That would be another 1/16 probability because it's the same thing, right? Probability of getting a heads here, tails here, heads here, and tails here. Then we also could have heads here and heads here. That's another option, right? And then we'd have tails and tails. Again, that'd be 1/16. And so on and so forth. So we can kind of see all the different ways that we could position the H. So then we could also have H here and here, H here and here, and we could also have H in the third position and here, and that's it. So we'd have another 1/16, we'd have another 1/16, and we'd have another 1/16. So add these up, 1/16 times, what is that, 6, right? That's 6 out of 16, which reduces to 3 out of 8. So this is sort of one way to do it with the multiplication. And another way is, again, we can map out all the different options. So I'm going to do that now. So what I've done here is I've mapped out every single possibility of these coin tosses, right? And there's actually going to be 16. That makes sense because think about it. Each coin toss has 2 outcomes. So it's 2, 2, 2, 2. 2 times 2 times 2 times 2, because it's 4 tosses, is 16. So there should be 16 total outcomes. Now we need to circle everything where we've got exactly 2 heads. So I've got 2 heads here, that's 1. Here, that's 2. Here, that's 3. And here, that's 4, and here, that's 5. And sorry, one more here, that's 6. So again, that leads us to this idea of 6 out of a total of 16 outcomes, which will reduce to 3/8. So that's 2 ways to think about it. That's how you do it. Done. Find the probability of tossing 4 heads or 4 tails. So the thing about 4 heads or 4 tails, so 4 heads, it's quite straightforward, right? We have probability of getting a head every time is 1/2. So we have 1/2 for the first, for the second, for the third, and for the fourth, right? And that's going to be 1 out of 16 because we're going to multiply all of these. So that's 1/16. That's for the heads. What about for tails? It's going to be the same thing, right? 1/2 of a chance of getting a tails, and then for that's 4 different tosses. So 1/2 times 1/2 times 1/2 times 1/2. That again gives a probability of 1/16. Now, since it says or, that's the union. We're adding these probabilities. 1/16 plus 1/16 is 2/16, which simplifies to 1/8. So the probability of either getting 4 heads or 4 tails is 1 out of 8. That's how you do it. Done. Find the probability of tossing not all tails. Well, since I know that the probability of tossing all tails is 1 out of 16, and I can verify that by, again, doing that calculation, which is a probability of getting a tail once is 1/2, and then for 4 tosses, it's 1/2 times 1/2 times 1/2 times 1/2, which gives this nice probability of 1/16. The probability of not doing that is the complement of this event again. So there's 1, right, for the probability of all the different things happening. So I basically take 1 minus 1/16. It's everything else, and that's going to be 15 out of 16. So that's my probability of not getting all tails, 15 out of 16, done. Find the probability of tossing either 2 heads or 3 heads. So we need to calculate the probability of 2 heads, 3 heads, and then because of that union, we're adding them together. So let's write out all the different possibilities first. So here are the 16 different ways that we can get 4 coin tosses, right? So we're looking for now all the ways that we get 2 or 3 heads. So let's circle those now. So let's count up everything where we see 3 heads first. So I see 1, 2, 3, and 4. So we got 4 there. And now let's circle everything where we have 2 heads. So we've got 1, 2, 3, 4, 5, and 1 more up here, 6. So in total, we've done 6 plus 4, which is 10, and out of the total of 16. So we got 10 out of 16, and that reduces to 5 out of 8. So there's my probability of getting 2 or 3 heads, 5 out of 8, boom, done. So for this one, we're finding the probability from a standard 52 card deck. What are the odds of getting a 2? So we got to think about a deck. There's 52 cards, 4 suits. How many 2s are there in that deck? There are actually 4. There's a 2 of clubs, hearts, diamonds, and spades. So there's 4 ways to win, as I put it, out of a total of 52 total possibilities. And there's our probability. The only thing we might want to do is reduce it by dividing top and bottom by 4, just like a fraction. So that reduces to 1 out of 13. That's the winner. Boom, done. So out of a deck of cards, getting a red 6, there's only 2 red 6s. There's the diamond and there's the heart. So there's 2 6s that are red. Out of a total of how many cards? 52. So this is pretty much our final answer for probability. Number of ways to win out of the total universe of possibilities, but we can reduce that. Divide top and bottom by 2. That's 1 out of 26. That's the answer. Done. So here we want to get the probability of getting a non-ace, meaning anything other than an ace. Well, first we need to know how many aces are there in a standard deck. There's going to be 4, right? 1 for each suit. So if there's 4 that are aces, non-aces would be 52 minus 4, which is 48. So my probability of getting a non-ace is 48 out of 52, and that can be reduced by dividing top and bottom by 4. So that reduces to 12 out of 13. That's the winning answer. Done. For the following exercises, 2 dice are rolled and the results are summed. Construct a table showing the sample space of outcomes and sums. So I already have an infographic prepared with this information, so I'm going to paste that up here now. So these are all the options, and you notice that there's actually 36 different outcomes. That makes sense because one die has 6 outcomes, the other one has 6. 6 times 6 is 36. And here are all the sums, right? We get 1 and 1, that gives us 2, that gives us 3, that gives us 11. A couple things that are interesting to note. The sum that is most common is 7, right? There are 6 ways to get a 7, and then it goes down from there. So anyways, that's what the table would look like. This would be the sample space of outcomes and sums. Boom, done. Find the probability of rolling at least 1 4 or a sum of 8. Okay, so we're going to use this table to our advantage. This is pretty cool. So, and again, it's or, so this is going to be the union of events. So let's first figure out how many ways are there to get an 8. I see 1, 2, 3, 4, and 5. Okay, so there's 5 ways to get an 8. And now it also says at least 1 4. So let's circle everything where there's at least 1 4. So I see right here, I see this one. I see this one, that's at least 1 4. I see this one, all of these basically in this column, boom and boom. And then we also got to go here. I also see this, this. Notice I'm not circling 8 twice. We've already circled it. We've also got this one and this one. So we're taking the union, okay, of all of these together that I just circled. So now we got to count these up. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that's 15 out of, again, I told you earlier that this is a total of 36 outcomes, right? 6 by 6. So 15 out of 36, divide top and bottom by 3. That becomes 5 out of 12. That's the probability. That's how you do it. Done. Find the probability of rolling a sum greater than or equal to 15. All right, so when we look at all the possible summations, right, the highest this goes is 12. So getting a sum when you roll 2 dice greater than or equal to 15, there's none that give you a sum over that's 15. So we've got 0 out of a total of 36, which simplifies to 0. There's 0 chance of getting that. That's how you do it. Done. Find the probability of rolling a sum less than 6 or greater than 9. All right, so what's less than 6? That would be 2, 3, 4, and 5. Why did I not include 1? Because 1 is not a possibility, right? We got 2, 3, 4, and 5. And then greater than 9 would be 10, 11, and 12, right? 10, 11, and 12. So the nice thing about this diagram, since it also states the probabilities down here, we can just take the sum, since because of that or word, of all those probabilities and all these probabilities. So it's going to be 1 plus 2 plus 3 plus 4. That's 10 out of 36 for those less than 6. And then we've got 3 plus 2 plus 1. That's 6 out of 36 for those greater than 9. Add those together and we get 16 out of 36. Divide top and bottom by 4 and we get 4 out of 9 for the win. That's how you do it. Done. Find the probability of rolling a sum of 5 or 6. So again, 5 is right here, 6 is right here. Those are the two corresponding probabilities. And when we see that word or, we're adding them together. So 4 plus 5 is 9 out of 36. Divide top and bottom by 9, and we get a probability of 1 out of 4. So the chance is 1 out of 4. That's how you do it. Done. For the following exercises, a coin is tossed and a card is pulled from a standard deck. Find the probability of the following: a head on the coin or a club. All right, so let's think about what's happening here, right? We've got a total of 52 cards in the deck. And if we're doing heads or tails, that means we can have heads and every outcome of the deck, tails and every outcome of the deck. That's 104 total possibilities. So the outcomes would be heads and clubs, heads and spades, heads and hearts, heads and diamonds, okay? And so there's 13 ways to get all of these, right? Heads, and then there's 13 clubs out of 52, so on and so forth. We could also get tails and clubs, tails and spades, tails and hearts, tails and diamonds. Again, there's 13 options for all of these. So if we're saying we can get head or a club, all of these are going to be winners. That's 52. And then we also have to include this group where we can get a club, all right? So what is this? This is a total of, again, 104. And what we count as winners would be this 52 plus another 13, which is 65. Now we can divide the top and bottom by 13, and we get 5 on top over 8 on the bottom. 5/8 is the winner. Done. So this one says a head on the coin or a face card. So again, it can be in either case. So in every deck of cards, we have aces through 10s. Okay, these are not the face cards. These are the number cards. So that's 10 cards right there. Then we have a jack, queen, and king. These are considered face cards, right? And again, we have 4 suits. We have spades, clubs, hearts, and diamonds, right? So we have 3, 3, 3, 3. That's going to be a total of 12 face cards. So again, we've got two kind of ways that we're going to get possibilities of combinations here. We're going to get head, and then we have any of those possible 52 cards that we can draw. And here it doesn't matter what we draw, whether we draw a face card or not, because a head alone is going to be what they want. That's what we're looking for, that probability. Then we got the possibility of getting a tails. Now, if we get a tails, we have to get a face card to qualify as quote-unquote winning, right? So since we know that there are 12 ways to get face card, when we get tails, right? Because there's only 12 face cards in the deck, 3 per suit. This is our total ways of winning, 52 plus 12, which is 64. So it's going to be 64 out of a total of, once again, 52 outcomes total for heads and tails, so that's 104. So dividing the top and bottom by 8 to simplify this, we get 8 over 13. And that's how you do it. Done. For the following exercises, use this scenario. A bag of M&Ms contains 12 blue, 6 brown, 10 orange, 8 yellow, 8 red, 4 green. Reaching into the bag, a person grabs 5 M&Ms. What is the probability of getting all blue M&Ms? So if we count these numbers up, we see that we have a total of 48 M&Ms. Now to calculate this probability, right, we're going to basically set up a fraction, and we're going to do a combination on top of a combination. So what we're doing is we have 12 blue M&Ms, right? So we're going to do a total of 12 blue, and we're choosing 5. And to get the probability out of this entire thing, we've got a total of 48, right? And we're choosing 5 here, right? So we're choosing 5 out of this total 48, and we want to see what is the likelihood of choosing one of these 12 blue M&Ms. Again, choosing 5 M&Ms. So if we evaluate this in Desmos, we'll get our answer. So here we get 1 over 2162. So the odds are 1 out of 2,162. That's how you do it. Done. What is the probability of getting 3 blue M&Ms? Okay, so again, we're grabbing 5 total, right? So to set this up, we want to take, all right, what is the probability of getting 3 blues, which is we've got 12 total blues, choosing 3. Now, the interesting bit is we have to multiply this by the combination of choosing the other ones that are not blue, right? So how many other M&Ms do we have that are not blue? We have 36, and of these, we need to choose 2. And then all of this is divided by our total, which is 48, choose 5. Because again, we're choosing 5 total. And if we evaluate this, this is going to give us our answer. Let's do that now in Desmos. And here we have 175 over 2162. So 175 over 2162 is the winner. Boom, done. In the game of Keno, a player starts by selecting 20 numbers from the numbers 1 through 80. After the player makes his selections, 20 winning numbers are randomly selected from numbers 1 through 80. A win will occur if a player has correctly selected 3, 4, or 5 of the 20 winning numbers. What is the percent chance that a player selects exactly 3 winning numbers? So here, the way we have to start is, since there's 20 winning numbers, we'd start on top with 20, choose 3. And then the remaining 17, right? We have to multiply that. We have to assume we want exactly 3. The remaining 17 have to be wrong. So how many wrong numbers do we have to choose from? We have to choose 60, and we need to get the remaining 17 from those incorrect ones. And then we divide this all by what we're choosing in total, right? So we are taking 80 numbers total and choosing 20. Once we evaluate this, we'll get our answer. Let's do that now in Desmos. So here we get approximately 0.1249 if we round it there, and converting that to a percentage, that will be 12.49%. So that's the percent chance. That's how you do it. Done. What is the percent chance that a player selects all 5 winning numbers? This is pretty interesting because this is probably what a lot of people want to know. So to get all 5 winning numbers, what we're going to do is we're going to say, hey, we want the combination of, out of the 20, we want to choose 5. Now, for the remaining, we have the rest of the other 20 numbers we're going to select. And since we're selecting 20 total, we need to select 15 here. And how many non-winning numbers do we have? 60. So 60, and then we're selecting 15. And again, this is divided by our total, which is 80 numbers, choose 20. Let's evaluate that in Desmos. And here we have our probability of selecting all 5. It's 23.33%. So 23.33%. That's how you do it. Done. How much less is a player's chance of selecting 3 winning numbers than the chance of selecting either 4 or 5 winning numbers? So let's calculate the chances of winning 4 or 5. We're going to add those together, and then we're going to subtract the probability of winning, getting 3 winning numbers. So let's set that up here, and then we're going to evaluate it in Desmos. So we're going to say we've got 20 winning numbers, right? And we're going to choose 4 of those. And then we have to multiply that by the combination of the 60 incorrect numbers, choosing our remaining 16, okay? And all of this is being divided by combination of 80 total numbers, choosing 20, right? And then, so this is 4 numbers. Now we have to add this to getting all 5 correct. That would be 20, choose 5 out of the correct values, times a total of 60 incorrect ones, and we're choosing the remaining 15 from there. And this is over the combination, once again, of 80, 20, as they all will be. And then last but not least, we're minusing the combination of getting just 3 winning numbers. So 20, 3, and then the remaining 60 incorrect. We're choosing 17, again, just to get that full 20. And then this is divided by 80, choose 20. All right, let's check this out in Desmos. So here we go. Here is the setup. And once we put it all in, we get 31.34%. So 31.34% for the win. Boom, done. In 2013, there were roughly 317 million citizens in the United States, and about 40 million were elderly, which is 65 and over. If you meet 5 U.S. citizens, what is the percent chance that exactly one is elder? So the way we can kind of set this up is, first, we want just one that is elder, right? So out of the 40 million that are elderly, all right, we're hoping to choose just one. And then for the remaining 4, right, we're going to do combination. And out of the total population that is not elderly, which is 317, removing that 40, that would be 277 million. We're going to choose our remaining 4. And this is all going to be over that total combination of the total population, which is 317 million, choosing 5 total. So let's evaluate that in Desmos now. And here we get 0.3678, which as a percentage is 36.78%. And that's how you do it. Done. If you meet 5 U.S. citizens, what is the percent chance that 4 are elderly? Round to the nearest thousandth of a percent. All right, so we need, of the elderly population, out of 40 million, we're going to be choosing exactly 4 from that group, and then multiplying that by the remaining 1 that we need to choose out of that 277 million. I'm getting that from 317, taking away the 40 million elderly. So out of the 277 million, we're choosing 1 person, non-elderly. And again, this is divided by the big choice, which is out of the total population, 317 million. And we're choosing 5 in total. Let's see that in Desmos. And here we get 0.0011, which would be 0.11%. So the answer is 0.11%. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.